So in our important clarification series, so we are going to be looking into understanding data science and analytics, the types of analytics and the processes that are involved. So that when you pick up a data set, you should be able to understand then what exactly do you want to do, uh, what is involved, what are the capability and advantages you can actually get from this data that you have just gotten. So we've noticed that a couple of several questions are coming in this direction. We felt it is necessary for us to clarify. And then there are a couple of other also misconceptions that will be cleared, but I'm not sure it could be done in one session, maybe subsequent sessions. On the difference between data science and machine learning, data science is not machine learning. You see, so what does it mean? What is the meeting point between the two? We've seen even experienced AI practitioners thinking that machine learning and data science, they are the same thing, but they are not the same thing. So we're going to have, hopefully, a talk on that later. And data science is not big data. Another very confusing scenario. Data science is not big data. So, however, big data is part of data science. Data science is not machine learning. However, machine learning is a tool for data science. These and other possible confusing scenario and terms or terminologies hopefully will be explored as we move forward in this special clarification series. After which, God willing, inshallah, we're going to revert back to our analytics for crop production boosting and also animal production and then other areas. So let us all follow up and then see how far we can go. So we are used to this, seeing this regularly in our presentation, which we call the machine learning iterative modeling process, which always give us that particular leeway to come back and forth. And then we always know when is it enough and when is it not enough. Mind you, in our clarification series, we have this terminology here, which is one of our working principle. Always let the data speak. So if you don't implement it in an appropriate manner, you may miss the information that the data is having for you. So in order to avoid such scenario that you miss information in the data, we have to follow the best practices in data science and machine learning utilization for this purpose. And that is what we always show. When you do your data preparation, you have the feature engineering, a lot of things are optional here. So don't do too much preparation so that you don't miss important information. Once the data it can be modeled, put it into modeling algorithm in machine learning, and then get the performance measure, check it. If it's okay, you are done. Otherwise, go back, do hyperparameter optimizations, and you may have to go back and change the algorithm altogether. You may have to combine several algorithms, as the case may be. And sometimes you may have to go back all along back to the data area, preparation and feature engineering, which we've explained a couple of times and times. However, today we are going to look into the modeling process is data science and analytics. And I've said it, we'll come back to explain that in detail later, that data science is not machine learning. So whenever you hear machine learning and data science, almost every day now, they are almost interchangeable, they are being used interchangeably, but it is wrong. See, machine learning is totally different from data science. However, data science is a field that is also taking the world. The data science is not a new idea. It's not a new field. It's been here for long. If you remember, sometimes in the past, when people get to the field to collect data, they will come back and do, I want to analyze my data. They send it to people who can do the analysis for them. That is data science and analytics. It's as old as we can imagine. Usually they use statistical, they use SPSS and other statistical modeling approaches, and maybe regression analysis and the likes. However, as we keep advancing, then machine learning came in. Machine learning is one of the latest areas in AI, in artificial intelligence, people now discover that with machine learning, we can do data analytics better than what we were able to do with statistical or statistic method. So because of this, people started rushing to machine learning for data science and analytics. So making people to now think that data science is almost the same thing as machine learning. But no, machine learning is just a tool that you can then use to solve your data science and analytics problem. Without machine learning, you can still do data science without recursing to using machine learning. That's why today we're going to clarify a little bit of this and see how far we can go, especially knowing the analytic approach you want to use. So when you get data set, it could be data set from agricultural practices or crop production, animal production, oil and gas, anywhere. The first thing is in data, if you can see here, we say modeling process in data science and analytics. So you have to understand the business environment where you really want to do the modeling. I mean, where you want to use data science analytics. So because data is now considered to be the next oil and gas. See, if you're able to make use of those data, and data is easy to get now, it's everywhere. That's why we start talking of big data. So much huge amount of data is being generated. If you have your phone is generating data, your laptop is generating data, some smart wristwatches are also generating data. So data is being collected from multiple angles. So because of this, we have a huge amount of data. However, this data will be useless if we cannot analyze it in an appropriate manner. But if you can analyze it, we have seen companies that are not in the Fortune 10. Within few years of using data science and analytics, they were able to get catapulted to one of the topmost 3 in the world. And that is the power of data science and analytics. So we can no longer ignore it. Also, when you look at, we get data, you look at the business, your business understanding is very important. You try to understand what is being done in that area. And then once you see it, you see the nature of the business, what they are in need of. Then you now determine the kind of approach. Which kind of analytic approach do I need? Because we have 4 types of analytics that you can think of. We are going to see them in detail shortly. We have what we call descriptive analytic. Then we have diagnostic analytics, and then we have predictive analytics, and also we have prescriptive analytics. So depending on what you want to cash in, what are you targeting in your company? What do you want to benefit from this data science and analytics? Which kind of area do you want to take the advantage of? This will determine how you are going to model your data. Sometimes you may have to use more than one type of analytics on your data. Most likely, descriptive analytics is always common to most projects because this is the basis. You want to understand what has happened to your data. What has really happened? So this is usually past tense. The data is already has been collected. You can't change the data. You can't change anything about the past. Then you want to understand what has happened in the past. That is descriptive analytics, so that you can learn lessons and then start looking forward to, okay, how can we prevent what has happened if it is negative? If you see some negative things from your data collected across your branches, then you start thinking, oh, what can we do to prevent this disaster? Or moving forward, if it is positive, how can we sustain this positive report? Or how can we improve upon it? This will lead you to other types of analytics depending on the need. In several cases, descriptive analytics is all what your client needs, and it's enough for them, and they're okay with it. So this is why you can do some data analysis without using machine learning, without using even sophisticated statistical analysis. We're coming back to this. So once you establish the kind of data analytics you want to use, then you can as well start following the other process. But then let's deal with these analytic types that we just mentioned so that you can understand it. It's very important. You see, as you move on in the ladder here, these are the types of analytics. we can encounter. So once you get your data, you try to look at it. See, this is, and you can see value. The value keep increasing. And then the level of difficulty keep going as you go this rightmost. You see, if you want something really very good, very excellent, you have to work for it. Nothing comes with ease. So you can see added value as you go up, but at the same time, there's also difficulty, challenges of having it. So once you have your data set, your client might understand what they want. So as a data scientist, you want to solve some problem for them. Some of them don't know what they want, actually. So you have to guide them after you understand the business. That's why business understanding is very important. Understand what they are doing, why they need, what benefit can they take from their data. This will determine the kind of analytics you are going to prescribe for them and that you're going to build for them. So here we have 3 categorization. We have the hindsight. That is, this is looking behind. It has happened. It is a past tense. So you collect your data from the field. What is the sale in the past 2 months or in the past 1 week across different branches of your company? See? So you run what we call descriptive analytics on them. That is, you are asking a question, what happened? That is what we mean by descriptive analytics. And it's often common to, it's usually a preliminary stage in most projects, because most projects want to understand what has happened. Then moving forward, we can then be able to know, okay, how to get things better. So, and sometimes the only thing a business may just be descriptive analytics, and they stop there. They say, thank you very much for analyzing our data for us. We are okay with this. At least we know what is happening in our branches. They are not yet ready to take it to the next level of insight and then foresight. They are more comfortable having descriptive analytics, which is okay. But that means they are not maximizing the power of data science and analytics. So this is what we call descriptive analytics. And in most projects, it's very much necessary. We can almost say that it's compulsory. You have to do exploratory data analysis first, trying to understand how the system is working, try to understand how your business is faring. But note that you are answering the question, what happened? So here you use mostly statistical tools or method. For example, you can draw the bar chart. Bar chart could be used. Pie chart. You want to understand the side, the branch that is making more sales. And then you want to know who are the customers. Do we have more male or more females? All this kind of information, you can visualize them so that then manager can then see it and say, oh, this branch is doing fine. So you analyze what the data are already. You can't change anything there because it is in the past. So we call it descriptive analytics. You are having an insight of what has happened. And knowing it is the beginning of taking proactive decisions in your company. So the next stage is, okay, we have seen what happened. The next thing is, if you want to take it further, do you want to know why did it happen? This is what we call diagnostic analytics. See? So this is what we mean when we say here, once we have the business understanding, you have to know which kind of analytic approach do you want to use. It's very important. So once you understand the different types you can have, then you can be able to decide which one is good for you. Sometimes you need only 2 of them. Sometimes you need 3. Sometimes you need all the 4, depending on the kind of business you are into or that needs your service. So diagnostic analytics is about why did it happen? Why did it happen? So on the what happened descriptive analytics and the example of crop production we discussed several times, you want to understand the pattern of yield based on the input you have provided. You have several farms. In this farm, this is what you have. In this farm. Then diagnostic analytics will now try to answer the question, Why did it happen? Why did farm A has more yield than farm B? Why is farm C growing back to negative, even though it was leading before? This is called diagnostic analysis. You are not just comfortable knowing what has happened. Why did it happen? That is the question of diagnostic analysis. Then you start running different feature engineering analysis, try to understand what could be responsible for this. Why is the sale in city A lower in this month, even though at the beginning of that month it was getting higher, suddenly it went down. See, then you can be able to take proactive decision to prevent it from happening in the future. This is what we call diagnostic analysis, trying to understand why it happened. However, taking to the next level, we are already in the insight now. We already left hindsight behind. This is just about past tense. No, we are trying to understand. We want to have insight into it. What made it happen? If you know why it happened, then you may be able to take decision. We call it proactive decision making to prevent it from happening if it was negative consequence. If it was something positive, then you want to continue to ensure that it will continue to happen. Then the next type of analytics is what we call predictive analytics. At this point, we are moving away from just insight. We are going to foresight. We are going to foresight. You see, diagnostic analytics will make us to have insight to why the kind of data we obtain from our branches. But taking it forward, we want to know why did it happen? What are the insight? What is responsible? Then predictive analytics takes it to the next level. See, and that is where the leading fortune companies are taking serious advantage of things. Majority will stop at this level, others move to diagnostic level and then stop. They then leave the manager to take some decision to prevent whatever negative consequence reported in the data set. However, people want to take real huge advantage of this technology. They go to the predictive stage. This is where, having understood the nature of the data, why some things happened, then you want to actually say what will happen. You're taking it to the next level. What will happen in future? This is predictive analytics, and it's getting really very, very popular in organizations. You want to have an idea of what may go wrong in your company. You don't wait for it to go wrong. This is what we call, indeed, proactive decision making. The system will predict to you that, okay, so branch may suffer customer dissatisfaction next month. Why? Why is it going to suffer it? Then you start, because in that period, you start to analyze it. Why will that happen? Because there are going to be huge customer presence in that branch. Since you have this idea that, okay, then you can be able to deploy excess workforce from one branch that is going to have low patronage. You can deploy them to the area where you're going to have high patronage, thereby preventing your customers from complaining or being disadvantaged or from not having the service that they are supposed to get in a very fast and quick manner. Imagine you are able to have an idea that one of your staff may be absent from work tomorrow. What about that? That is predictive analytics. You see, that is predictive analytics. You want to have an idea that, okay, this social staff will not be present tomorrow at work. So the manager runs the predictive analytics towards the end of the day and then calls the person, Mr. So, we're going to have special visitor tomorrow. So, and then we hope you are going to be at work very early. Meanwhile, this guy was already thinking of not coming to work. He was thinking of being off. But now the manager called him. Why? How? Why is he calling me at now? Why not another person? Because the predictive analytics has identified. We call it absenteeism predictive solution. Based on past experiences, lot of data set that has been analyzed, they were able to identify that this person will be absent. And also for that predictive analytics that can be done. That is, you having idea of what may happen. When you have predictive analytics, it's not that you are predicting doom, but you are actually having an insight into what may happen so that you can actually prevent it from happening. Let's bring it to our educational system. Imagine at the beginning of a semester, a lecturer can run a predictive analysis to know, to have an idea of students who may fail the course. Because if based on students in the past who failed the course, we can be able to predict new student characteristics based on their new characteristics of the new student, the features, either feature from secondary school, they are just coming to the university. We may be able to predict why they are going to pass this course or not, either based on attendance, based on performance in the previous courses that are related to this course, and also further feature we can use. We are not hoping that those students will fail, but rather the teacher will be aware of the number of students that may fail, and then may have to bring up a lot of extra efforts, tutorials, group studies to prevent those students from actually failing. So this is proactive system. Predictive analytics made this very much possible. That is, we want to have an idea of what will happen. You want to have an idea of students who may get involved in vices in the university. You can use predictive analytics to have this idea. You want to know students that may get involved in unwholesome activity on campus, like joining secret cults and the likes. The moment they enter the university, you want to have an idea of them because there are huge data of people in the past who join such society and those who doesn't join. Once you understand their characteristics, you can have predictive analytics that can give the university administrators an idea of what may happen. And the idea is to prevent it from actually happen. You want to have an idea of students who may drop out of his university. Because a dropout of university may be a potential threat to himself and to his family and even to the community and the society at large. Why don't we support our students by having an idea of what may happen to them earlier, and then we may have a kind of proactive decision making. It's like when you have accident predictive solution that tells us, okay, there might be some accident at some point in time. Alert will be sent to the traffic police. The traffic police will mount roadblock close to those joints of high predicted to be expected to have very high accident for that day. And then by mounting roadblock, they can slow down every car that is arriving at that point, thereby not making that prediction to come to reality. That is the essence of predictive analytics. They don't know the future, but they have an idea based on previous incidences. Just like today, you can have an idea of if there's going to be rain or not. Even though it's not 100% perfect, but things are improving with improvement in several algorithms that support predictive analytics. So when we talk of predictive analytics, this is what we mean. What will happen? And there are so many types, and depending on the business environment, you are implementing it. So we've talked about descriptive analytics, what happened, diagnostic, why did it happen, what will happen, predictive analytics, and last but not the least, how can we make it happen, which is called prescriptive analytics. How can we make it happen? So you have some characteristics that you want in your product. You see, how can we make that product to become a reality? Then it has to test different combinations. We call it AI optimization. You want to optimize. You have some unique characteristics. These are heavily used in drug production, vaccine production, and others. And that is why some of the drug production processing are getting faster than before. Before data analysis, you have to go to the lab, combine different chemicals and see the outcome, combine this one and see the outcome. But now with prescriptive analytics and huge data from the past experiments, then you can do a lot of random combination and then come up with, okay, if you want these characteristics, these are what the input you have to provide to the system. If you want these characteristics, these are the input you are going to provide for the system. This is why we call it prescriptive analytics. That is, how can we make something to happen? How can we make a desired scenario to come to reality? So those are the 4 major types of of analytics that often encounter. Of course, of recent, we start hearing visual analytics. Visual analytics is just try to combine visualization with predictive power. Visualization is usually part of descriptive analytics. You want to visualize your data and see what is going on. And after your result is generated, you also visualize it. But now we want to combine it with predictive power. Then we call it visual analytics. That is, it's not just ordinary visualization, but visualization that has been imbued with predictive power. However, the generic type of predictive analytics, they are descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. And sometimes in your data, depending on the business area you are working on, your data may need the 4. You may need to carry out the 4 types of analytics. Sometimes only 2 is enough. You just do the descriptive analysis, and then you go to predictive analytics. You have to always, most cases, descriptive analysis is very important. We have to understand your data. We have to understand where your data is coming from and some characteristics of your data, some statistical description of your data, the mean, the standard deviation, the mode, and all those kind of basic statistical analysis. Is this skewed to the right? Is this skewed to the left? And some other, you want to have a bar chart of your program, of your data set. Next time we can jump to predictive analysis, if that is what. Next. Hello, can we hear me, please? Are we hearing me?
Yes, sir, we can hear you.
Okay, thank you very much. Yeah. So these are the 4 main type of prescriptive analytics, as the case may be. Yeah. So once you determine the kind of analysis that you want to do, then you start gathering your data, you look for the data requirements, then the data collection will come in. So data collection, have an idea of what you want to do. You already have the understanding of the kind of analytics you want to go for. Then you start gathering your data collection. So then try to understand the data. Also understand the data, is it in line with what we really want to do? Can we benefit from it? Look at it. There's always a 2-way flow. You can always go back, review what I've done. So once you are done with your data understanding, then you prepare the data. Preparing the data, you may have to go back to collection again, that what you had is not enough. You may have to go back and then return back to data preparation. If it is ready for modeling, then you go into modeling. You see, it is that modeling, then you can then see, okay, which kind of model am I going to use? Am I using only statistical modeling, or am I using machine learning modeling also? Sometimes you combine the 2. Yeah, this is why we say data science is not machine learning. We'll come back to that one hopefully later in the future. So you have to go into modeling. You can always come back from modeling back to data preparation if not, it's not well done. And then evaluation is there. You evaluate your results. Is it okay? If it's not okay, you can always go back. It is when you are finally satisfied that, yes, I think what we have gotten is more than enough, is better, then, of course, there's always room for improvement. You are the first one to work in that area. Go ahead, see what you can get. Other people can always come behind to also improve upon your work. But if people have worked in that area before, you always have to try to beat what they have gotten to make your work worthwhile. Then you have to think of deployment. So deploy it to the production level whereby people can then use it in the business area. Of course, continuous feedback. may necessitate that you have to do maintenance, modeling. You have to again model it, redo it to make it better, especially as more data sets are becoming available. This is in summary some of what we can refer to as modeling process in data science and analytics and their types. So we'll give room for question and clarification in case there is. I believe then subsequently we're going to look into what do we need to do descriptive analysis, what do we need to do diagnostic analysis, prescriptive analysis, and prescriptive analysis. Is it statistic or is it machine learning or is it both? Or we have other types. This is another clarification related to this we are going to be discussing. And then the building block, we are going to look at them. And then other clarifying point we'll be looking to. Thank you very much for listening. So I believe it's a good time to call it a day so that we can ask a couple of questions if there is. Thank you very much for listening and have a very nice time. Thank you.